Hello, it's another great day for math. This is question 2, and we have a regular polygon and a pentagon, and obviously the topic that's needed is the topic on polygons. So naturally, when you do this question, actually the first thing that, or rather the first concept that comes to mind should be the total interior angles, right? And in particular, we have a pentagon, which is five-sided, meaning the letter N is represented by 5. So the total interior angle of any polygon is n minus 2 times 180, which is, meaning with a 5-sided figure, the total interior angle should be 540 degrees. Now, on top of that, this is a regular polygon. So all these sides are equal. On top of that, it means the internal angles are also all equally divided. So each internal angle, everyone, or rather each interior angle, is 540 equally divided among the 5 corners. So that gives us 108 degrees. So this is a total of 108 degrees. Now, if you focus on this particular triangle, did you notice that it's isosceles? So if that is isosceles, it means that I can find actually each individual base angle here. Okay, so the base angle, let's call it angle AEB. It's basically 180 degrees minus the top 108, and I divide it by 2. And that gives us 36 degrees. So each one is 36 here. Now if you look carefully, and I flip the pentagon around, I have another congruent triangle here with the exact same dimensions. Interior angle 108 and base angles 36. So with that, it means that angle EAF is 36 degrees as well. And therefore, angle AFE, let's call it this red angle here, AFE, will be the subtraction of 36 twice to give us 108 again. So therefore, we can now finally find angle AFB by taking 180 minus 108 to give us 72 degrees. And there you go.